welcome to the video on partial derivatives. So what is a partial derivative? So basically, in order to explain what a partial derivative is and why we take it, is that it's important to understand that a function of two or more variables, so let's say we have two or more variables in a function, two or more variable function, okay? It doesn't have a unique rate of change, so no one unique rate of change, because each variable, so for example, let's say we have an x, a y, and a z or something, each variable, which is independent, right, each of these independent variables may affect the function f in different ways. So each variable may affect, there we go, our function, our function, in different ways, okay? So therefore, that's why we take the partial derivatives. So here's the function of partial derivatives and the reasoning behind why. So partial derivatives, I'll just abbreviate, are taken to study, so we can study exactly how each variable, so how each of these variables, affects our function, basically. That's the whole concept behind it. Affects our function. So, I'll go into more detail as to like how we're going to do this. So, for example, let's say we have an f of xy, okay? So f subscript x, so this notation here, that means the partial derivative, so partial derivative, with respect to x. So what does that mean? It's like, okay, are we being disrespectful to y, or I don't know what that means. So with respect to x basically means that what we're doing is we are treating x as our variable. So treating x as the only variable, which means also that we, at the same time, we're going to consider y, or any other variables that we do see. So in this case, it would just be y. Consider y as a constant. Okay, so that's just staying the same. Okay, so for example, the formal definition of our f subscript x is the limit as h goes to 0. And here's our definition of the limit, right? So a plus h in the x spot, and then we have a b minus f of a, comma b, and this is over h. So see here how our x spot changed, right? We have that plus h added in here, and then the a, but the b stayed the same. So that means that our y is staying constant, right? Y is a constant, and x is the one that is changing, okay? All right, so this is also equal to, this is measuring how much our function changes with response to a change in the x variable, okay, or in the x direction. All right, so x is our variable here. On the other hand, if we had f sub y, right, this is our partial derivative, so partial, and sometimes we refer to this just as a partial, just to make it shorter, like the partial with respect to y. So conversely, or oppositely, we're going to treat y as variable, and x as constant. Okay? So this one, we're kind of flipping the roles. So f sub y is equal to limit as h goes to 0 of f of a comma b plus h minus f of a b. And this is all over h. Okay, so see here how the x spot, there it's just a and a, right? That just stayed the same. X is a constant, and y is the thing that's changing. And actually, instead of an h here, we can put a k just for distinction's sake from the h above. Okay, so I'll just put a k in for that one. All right, so limit as k goes to 0 of f of a comma b plus k, that k is our change in y, and then minus f of a comma b, and then all over k. Okay, all right, and then the last thing here is just this f sub y is studying how much f, our function, is changing in response to the change in y. Okay, change in the y variable. All right? So let's do an example. How are we actually going to do the computations? So let's say we have some function, f of xy is equal to, let's make it kind of simple, so x cubed times y to the fourth. Okay, so what we're going to do is compute the partial with respect to x and the partial derivative with respect to y. Okay, so let's, first of all, let's do the x one. Okay, we'll start with x. So what this means is we're treating x as our variable. So this is basically saying the same thing as d dx of our f of xy. Okay, y is a constant, so that's just going to be considered a constant. So because it is a constant, we can just pull out this term here in front, right? Due to the constant multiple rule. So then we have d dx of x to the third, and we'll just use the normal like power rule here. So f sub x is going to be equal to y to the fourth times 3x squared, which we can rewrite that as a 3 times x squared y to the fourth. Okay? Alright, so now let's compute the f sub y. So this is the same thing. So this is the partial derivative with respect to y. So that means y is our variable and x is the constant. So this would be d dy of the same thing, x cubed y to the fourth. Okay, so now we're treating x as a constant, so we can pull that guy out in front. So this will be x to the third times d dy of y to the fourth. Okay, so that's what we have now. And then when we use the power rule, we just get x to the third times 4y cubed. And our final answer for f sub y is going to be a 4 times x to the third times y to the third. Okay, so that just shows you the basic computations. That's how we would do it. Again, when you're differentiating with respect to something, you're considering all of the other variables that appear in the original function as constants. Okay? Alright, now let's go over some more like conceptually slash like graphically. So what's going on? So conceptually slash graphically. Graphically. Not like formulaically as in like the definition of the limit. So let's say we have some kind of f of xy. Okay, so we're starting with some f of xy function. So let's start with, let's say it looks something like, I don't know, something like this. Okay, alright, so this is our f of x comma y. Alright, that's our surface up here. So if we were to do let's say the partial with respect to x, this is the one we're doing here. Okay, so if we do that, that means that we're going to consider x as our variable. So x is the variable and y is the constant. So y is the constant. So y being a constant, that's like if we were to do a trace, right? Do like a what is it? A vertical trace. So that'd be like setting y equal to b or something like that. Okay. So if we do that, let's say we cut it at b. So then we have our plane here, y equals b. That's the plane, the vertical plane I'm drawing right now. Right. So something like that, and that would cut like a vertical trace here. So something sort of like that. It would cut it through the curve. Okay. And now, so f sub x is basically describing the slope of this vertical trace curve. So this is the vertical trace curve, right? The one that I'm bolding right now. So the partial with respect to x is basically saying as x changes, as x goes like left to right or this way or that way, how is the function changing? So that would be the slope of the tangent line to the vertical trace curve. Okay, so this is, I'll write it down here. So f sub x is the slope of vertical trace curve at each point, right? So at whatever point you want to evaluate it at, but that's what it is. Okay. All right. So on the other hand, let's do let's see what f sub y is. So here's our x, y, and z. Let's draw something similar, right? So some graph that goes like that. Right. So here's the surface. That's our f of x, y. Okay. And then let's say we were to do, so again, here's our f sub y. So that would be the partial derivative with respect to y. So y is the variable. That's the things that's going to be going, that's going to be varying, right, or changing. Our x is the constant. So here we can set it equal to some constant such as a. So x equals a. Let's say here. Okay, so let me draw that plane here. Okay, this is the one facing us directly, like head on. Okay, so here's the plane, and it's going to cut a curve through something like this, let's say. Okay, so here's our vertical trace curve, the one I'm drawing now. I'm tracing it over. Okay, so our f sub y will be the slope. Again, this is a slope. So slope of vertical trace curve at each point for this one. Okay, the vertical trace curve formed by or obtained by taking the plane x equals a, this one that's facing us like a wall, right? Taking that and cutting it through the surface. So again, f sub y would be the slope at each of these points on our vertical trace curve. Okay? All right, so now let's go on to a different subject.